Hello guys, I'm Vaishali Kikan from Dopamine and we are discussing digital circuits. Today we are going to start what are the encoders in the digital circuits. We already have covered the decoders. If you have still not watched the previous video, you can go and watch them first and then come here. Now here we are going to start with the encoders, and the agenda for the encoders is like this. First of all, we are going to understand what are the encoders. We are going to understand its general structure. Then we are going to understand 4 to 2 binary encoder in detail. We are going to understand decimal to BCD encoder, which is a specific type 74XX147 encoder we are going to understand. Then we are going to understand decimal to BCD encoder, right, its truth table in detail and it's working with the help of the truth table. Then we are going to understand the priority encoder, its K-map simplification, priority line encoder. Then we are going to deal with the octal to binary encoder and the different encoder ICs and its applications. This is how we are going to wind up the encoders, and we are going to understand the encoders in detail. So basically encoders are the device which are going to perform the inverse operation of the decoders. So that's why I was saying that go and watch the previous videos on the decoders first. So whatever we have discussed in the decoders, encoders are going to do the opposite of that. It is again a multiple input, multiple output logic circuit. So here we have 2 raised to power n inputs and we have n outputs valued from 0 to n minus 1. So we have the output, the 0th output, the first output, till we have n minus 2th output and n minus 1th output in the general structure of the encoder. So this is the output side. We have the 2 raised to power n input. So this is my first input, second input, so on. We have up to 2 raised to power n input. So this is my input of the general structure of the encoder. Then we have the enables. So we have some enables from 0, 1 up to m number of enable lines we have. So enable is used for the activation of the given device. So it will convert any coded input into the any coded output. So the coded input is in such a way that it has 2 raised to power n input bits and the output bits are n numbers, right? So if the enable is unasserted, so all of the outputs of the decoder are disabled. So to get the output, first of all you have to assert the enable. So you have to see what is enable and how it is working. If it is active low, you have to switch it to 0. If it is active high, you have to switch it to 1. So you have to first of all check if the enable is activated or not. If the enable is activated, then this 2 raised to power n input can be converted into an output code. So input code is converted into the output code with the help of encoder. 2 raised to power n bit input code is converted into n bit output code. This is basically the general structure and the introduction to the encoders. Now coming to the 4 to 2 binary encoder, as the name suggests, it has 4 input and 2 outputs. So basically if I draw 4 to 2 encoder, so how many input I am going to draw? I am going to draw 4 input line. How many output I am going to draw? I am going to draw 2 output line, right? So these 2 output line are taken as y0 and y1. 4 input are taken as a, b, c, d, and we have one enable, right? So now when the enable is 0, whatever my inputs are, whatever a, b, c and d are, y1 and y0 both are 0, right? So if my enable is 1 1 1 1, so in that case a, b, c, d will vary. So based on a, b, c, d we are going to get the output. So if a, b, c all are 0, d is 1, we are going to get 0 0. If we have 0 0 1 0 as a, b, c, d, we are going to get the output as 0 1. If we have 0 1 0 0 as a, b, c, d, we are going to get the output as 1 0. If a, b, c, d are 1 0 0 0, we are going to get the output as 1 1. So this is basically the truth table of the 2 to 4 encoder. So you can make the line encoder also with the help of this, right? So you can use this as a line encoder. Simply you have to connect the output pin with the input pins. So you can see here the output here y1 is 0 0 1 1, and then it depends upon the inputs a, b, c, d, and you can use the K-map for the simplification. Right, now coming to the decimal to BCD encoder, and that again a specific type 74XX147 encoder. So here it is a 9 to 4 encoder. Here we have the 9 input line and 4 output line. It is an active low device, so whatever input we are giving in an active low manner, which means 0 is enabling it, right? And we are going to get the output in the, if the output is set, which means we are going to get the 0 as the output. So basically in this encoder we have the 9 input 1 2 3 4 5 6 7 8 9, right? Then we have the 4 output A, B, C, D. Now we have the different pins. So the output 4 is connected to the pin number 1. The output 5 is to the pin number 2. 6 to the pin number 3 up till 9. So we have 4, 5, 6 pin to the pin number 9, right, to the input 9. Then we have the 9, 7, 6 and 14. Then the pin number 11 is connected to the first input line, 12, 13. So this is how we have the pin structure. This is the decimal input. We are going to give the input in the decimal form and we are going to generate the output in the BCD form. Right, this is my 74XX147 IC. So these are the IC pin numbers, and from the pin number 9 we are going to get the output A, from the pin number 7 output B, from the pin number 6 output C, from the pin number 14 output D. This is how this IC is connected. So if we have the decimal value 0, for that everything must be set. So all of the inputs, all of the output must be set. So 0 is represented by all ones. So A, B, C, D and 1 to 9 input pins are all ones. For 1 we are representing it as 0, 1, 1, 1, 1, 1, 1, 1, 1, right? So only 1 is 0, rest all are ones. Then it is represented as 1, 1, 1, 0. 2 is represented as X0. So basically the first input pin could be anything, but the second should be 0 for the active low input of 2. So 2 pin should be 0, right? And then all are ones for the 2. Then its output should be 1, 1, 0, 1, right? Then 3 is XX0 and the output, other pins are all ones. So output will be 1, 1, 0, 0. So 4 is XXX0, all other are ones, then the output is 1, 1, 1, 0, 1, 1. 5 is XXXX0, 1, 1, 1, 1, right? Then the output for the 5 is 1, 0, 1, 0. Right, similarly you can see for 6, 7, 8 and 9. For 9 we have the 9th pin set to 0 and the output is 0, 1, 1, 0. So in the BCD output we are going to write whatever the BCD code for 1 to up to 9 and then we are going to invert it. Like for 1 the BCD code was 0001 but its invert will be 1110. So we are going to write that. For 1 it is 0010. So now its invert will be 1101. Right, for 3 it is 0011. So for this output it is active low, so it will be 1100. So this is how up to 9 we are going to get the input and the output for the decimal to BCD encoder. I hope you understood what is the encoder, what is decimal to BCD encoder, what is simply 4 to 2 encoder, right? If you have any doubt, you can put the doubt in the comment section. And you are going to meet me soon the next class where we are going to discuss the encoders in detail. So see you soon. Till then, bye-bye. Take care. Thank you.